Hi and welcome again on this new video about kernel memory and how you can extend kernel memory to support more model and more technique to search. In this video, I'm going to show you how I implemented with very few lines of code the ability to use Command R plus model to do the generative part of RAG. As a reminder, RAG is retrieval augmented generation, R is retrieval, and it's important part in which you are searching inside your data sources, and then A is the retrieval augmented generation, where you create a prompt in which you stuff all the pieces of information you find in your memory, and then you pass to a generative AI, to a large language model, to generate the answer of the user question. Okay. First of all, we need to have in mind that RAG is used mainly to use a large language model to operate on your data with a technique called grounding. So grounding is the technique used in the generative part of RAG that allows you to make your large language model answer to the user question using only the data from your trustworthy source. Because the large language model are generative AI models, they tend to simply generate next token based on the previous one, so they tend to hallucinate. So if you pose a question, the large language model can answer generating a thing that isn't factual. Also, even if the large language model usually have some sort of memory because they are trained on a large corpus of text and they can answer based on that corpus of text, they have a knowledge cutoff because training a large language model involves a lot of money and time. So usually you use a model that was trained months ago, so the model is not aware of newest information. Also, often you want the model to answer only with the data of your customer, of your company, and not using anything else. So traditionally, grounding is usually follow in the area of prompt engineering, where you are creating a special prompt in which you are instructing the large language model to answer only with the fact. So you usually start a prompt like, I will give you a user question. You can answer only using the fact that follows. If the answer is not found in the fact, you will simply answer, I don't know, and you never use your previous memory to answer. So this is a series of techniques you can use in your prompt for grounding the generation of the large language model using only the fact you are providing in the prompt. But this can be sometimes complicated because maybe you find a prompt that is perfect and then the model changes, or you're using a different model and the same prompt is not working perfectly. So we have some companies like Cohere that develop models specialized for RAG. Cohere is a company that has some models specifically designed for RAG. As an example, they have a re-rank function that is really good, but we are going to examine the Command R plus large language model. And what is special in this large language model is that Cohere trained this model and offer an API that can work specifically for retrieval augmented generation. And why I'm telling you that they train it specifically for RAG? Because look at this example. As you can see, you are specifying an API call to this model, Command R plus. In this example is the command, but we have new model Command R plus, and you are only specifying the user question in the message part of the API. And then you will specify a series of documents that are simply an array of unstructured JSON when you can use title, snippet, title, text. It's not important. So the important thing is you are creating an API, you are using an API that is specific for RAG, where you're specifying the user question and the pieces of text, the document you are using. And that is exceptional because what you expect from this call is Cohere did the grounding for you. So you don't need to understand how you can ground the model for doing RAG, because Cohere did this for you. And this is important because as Cohere will upgrade, will improve the model, and we will have new model from Cohere, we didn't need to change our prompt for maybe a new training of large language model. We all know that when the large language model change, the previous prompt could not work as well as before. So this is not an exact science. And if this part is done by the company that gives us the API, it's significantly simpler for us. Another super cool feature of this kind of API is that the answer contains the generative text that tells you the Telos penguins, blah, blah, blah. So the answer of the user generated by the large language model. But they are doing something more in the background. So they gives you a list of citations and a list of documents that gives you the idea which document were mostly used to answer from the large language model, and even gives you citations that tells you how well and where in the text the model find the interesting information to generate the answer. So if you have your classic RAG pipeline where you extract some pieces of text from your sources, you pass everything to the large language model, maybe you are passing 10, 20 pieces of text because now we have larger context, the large language model correctly answer the user question, but you don't really know which one of the 20 pieces of text contribute to the answer. So you can tell to the user, hey, this is the answer, and this is the 20 pieces of text I've used to answer. With this kind of API, it's the model, it's the API itself that in return gives you the list of documents that were used to answer the question. And how difficult it is to implement this in your kernel memory pipeline? Well, it's not difficult. In the latest version of kernel extension, you can find the link below, I've extended the raw Cohere client to being able to call this API. And I've done this in minutes because using the new GPT-4o, I was able to take all the specification of the Command-R chat API, I pass to the GPT and tell it to generate all the DTO in C#. So the code is really simple. I have a Cohere rank request and I'm creating an HTTP client, perform the question. This is very, very raw code, so it has no strong error checking. It's just verify that the call is successful, and I deserialize the string inside the Cohere reg response. And I have also the streamed version of this API. So with few lines of code, you are able to call this API. It's very simple. And now let's see how different is the step of the custom pipeline that using this API to generate the answer of the user based on the memory record you extract from your memory database. Now a disclaimer. When you use the generative power of large language model, usually in the configuration, you are specifying the maximum number of tokens you want to use for limiting the cost and the time used for the large language model to answer. So as I told you, you can do the query on your iMemory database, you can extract 100 memory, you can re-rank, and usually you pass 5, 10, and not a lot of memory record because the prompt will be really big. You're going to spend money to the API, to call the API, because you spend on the amount of token you pass. And so you usually specify a number of tokens you want to use and so on. But in this example, since we have still not a perfect tokenizer for Cohere, Cohere has an API that allows you to pass the text, and the Cohere gives you the tokenization back so you can understand how long in token is a piece of text. But it's not important in my opinion, because since we already have the chunking part of the kernel memory that is taking your document and chunk into a segment of approximately a certain number of word length, okay? So yeah, I know different models have very different tokenizer, but you know, if you take the tokenization of GPT-4 and maybe it is a piece of text is 500 token, we are not expecting the same pieces of text to be 10,000 tokens. So it's similar in number of tokens. It can be double, but it's not important. So for this example, I'm simply limiting the number of memory record I'm passing to the final model. So I'm telling in configuration, I want to use 5, 10, 12 memory record you will pass to this model for answering my question. And I'm not specifying the limit in token. It is enough for me. To understand the difference, I'm going to show you the original RAG query executor that is taken almost from entirely from kernel memory code. So it is very simple. It receives a number of memory record from the question pipeline, and then it starts using a string builder. So it's calculating the number of tokens, but basically what is important is it's cycling all the memory record you have, and it is creating a string. Basically, it's creating a prompt in which each memory record is inserted with a special syntax. So you see this special syntax is aimed to separate document between them, so help large language memory to have large language model to have a better context, and blah, blah, blah. You create a string builder, you append, and it's a little bit of code. It's not complicated, but it is much more complex than the Cohere command R plus generation, because this is really simple. As you can see, I'm receiving a number of memory records, same as the other executor, and then I take the number of memory record from the option. As I told you before, I specify the maximum number of memory record I want to pass to the large language model. I'm creating a Cohero RAG request from this memory record, and if I'm going to implementation, it's really simple. I'm simply creating passing the question, and for documents, I use the property doc.id and text. Nothing more complex. So actually, I have an async iterator because I'm using the async version of the API, so I can use the streaming API. As soon as command R is generating response, I can immediately give to the user, so the system, the UI is more responsive. I'm going to iterate, and if the response is text, I'm appending to the answer to the user. So look how simple it is. I don't need to taking care of creating the prompt. So the prompt for grounding, like you will answer only with, I don't care about anything of this. I call the API, I put the question, I put the memory record, I extract text, I stuff in the documents, send to the Cohere API, and let all the magic be done by the Cohere API. The interesting fact is, after I've received all the answer from the streaming API, I can take all the answer segments that are citation, because they contain citation, and from this I select all the document ID. I know that the API will answer with doc_0, 1, 2, 3, that it's containing the number of document. This is the example, okay? So you see this is the answer, doc0, doc1, and so on. So with this, I can extract the integer part, and so I can put into an hash set. So I need to create the citation answer to the user, and I can say, okay, from the all usable memory record, so from all the memory record I pass to the large language model, I pass to command R, I select all the one where the memory record ID, where the ordinal of the memory record ID contain the ordinal of my original memory record. So I'm simply using the answer from the command R API to give to the user not the original array of memory record I passed to the API, but the one that the API told me are deemed to be useful for the answer. So this is interesting because it allows me to give a more precise citation to the user. Now I've changed the example that is in my kernel memory extension console text. The file is the custom search pipeline base, in which I'm doing experiment on the custom pipeline. And I'm using the Cohere using 10 memory record as the number of record I want to pass to the large language model to answer to my query. Now let's look the example into action. So I'm gonna use the custom search pipeline basic. I'm gonna use Elasticsearch. I'm gonna use this time Query Command R plus, and I'm answering no because I've already indexed my document. So my kernel memory DB is already created in Elasticsearch, and I'm going to create a question. It's always the question: can you please explain complete mediation technique? And complete mediation, it's the verification keyword. Look at my previous video. It's not important in this example. I'm pressing return, and as you can see, I'm going into my Cohere command R RAG executor, where I'm calling the API. And if you look at the API, they seems to be slow. And this is because Cohere allows people to register and use API for free. So I'm using a free API and it's called the test API. And clearly the answer is slower because I'm using a free tier just to try out the model, but the model is fully functional. So now it's the important part. I have usable memory record and I have a count of 10 usable memory records. So I've passed to the large language model to Command R plus 10 memories. And then after I filter out with the citation, I have the used memory record, it's 3. So the important thing is we have two big advantages in using Command R plus in this scenario. First, I do not need to think to how I can ground my prompt, how I can ground the large language model to answer only with using the citation, because it is done by Command R itself. So I'm not doing anything difficult. I just call an API in which I specify the question and the list of JSON documents that I want to use to answer the user question. And after I've done this, I can simply wait for the answer, and from the answer, I know which are the documents that were used for the citation. So when I'm creating the citation map for the user to say, hey, this is the answer of your chatbot assistance, and these are the documents used to answer to the question, I can filter out all the non-relevant memory that were passed to the API. And this all for free because it is done by the Command R model and is done by Cohere for you. But that is not the whole picture, because if you look at all the citation messages that are contained inside the answer, I can cycle on all the citation as you can see. It gives me the document it used by as an important aspect. It gives me and the start, so the range of the original text that extracts some important part of the text used to answer the question. So in this example, validate access right to all its resources. So when you are presenting to the user the citation, so you can say, hey user, this is the answer of the chatbot, and these are the pieces of text used for the answer. You can, using this information, to highlight portion of the text, because that are the portion of the text that the large language model deemed to be relevant for the query answer. So you can give to the user a more detailed citation, and it brings to the user a very better experience. And the video ends here. As a recap, what we saw in this video is how simple it is to extend kernel memory to use a different large language model to answer user query, and how efficient is Command R plus model by Cohere, because it allows you to just specify the question and documents without worrying about how you should generate your prompt for grounding, and how you can use the answer to filter out the document to return to the user only the document that were deemed relevant to the question, so you can be able to build better citation. I hope this video was good for you, and the code is in my repository that is linked below, so feel free to get the code, use the code. I need to make it better production-like, but it works out of the box. Bye-bye, and see you on the next one.